Assalamualaikum and good day everyone. We will continue our SAS programming by taking to look at how do we perform statistical analysis using SAS. Okay, so we will continue with this particular topic, which is comparing means. And for this particular procedure, uh, the the procedure that we will use to do this particular test, such as one sample t-test, independent t-test, and pack t-test, is by using proc t-test procedure. Okay, and before you do your one sample t-test, you have to understand what are the hypothesis that you want to specify. Okay, and based on our example, we want to test whether the population mean equals to 45 years old. Okay, so means that the variables that we interested to study is age. Okay, and this particular variable is in data fitness. Okay, and um, before we begin, if this is your new session, okay, if this is your new session, okay, remember to run this first, okay, to make sure that the data fitness is in temporary temporary library. Okay, right. So let's take a look on how to use proc t-test. Okay, I will perform the one sample t-test first. It means that we want to test whether the population mean equals a specific null value. Okay, for this particular example, I use 45 years old. So we will use proc t-test, and then you have to give the data, okay, fitness, and then we specify the null hypothesis, and then the site. Okay, so for this particular site, it can be two-sided, lower, upper. This particular sites is actually depends on your alternative hypothesis. For two-sided, your alternative is the population mean is not equals to 45. For lower, for lower, the alternative hypothesis is the age is less than 45. For upper, the alternative hypothesis is the age is greater than 45. So for the sake of example, I just use this one, and then I put the significant value. Okay, and the most common one is 0.1, 0.05, and 0.01. So I just use as the same as example, 0.05. Okay, make sure that you put the variables. Okay, we want to test the hypothesis on each variable. Okay, and then you run. Right, and when you run this one, okay, let's take a look at the output. Okay, the most important outputs that you need to take a look is this one lah. Okay, this is the p value, and the p value rules is the same. Okay, if the p value is less than alpha, we reject the null hypothesis. Okay, so based on this p value, we fail to reject since that the value is more greater than 0.05. Okay, and besides that, you can also take a look at the graphic one. Okay, the test of normality of the variable age, since that if you perform the t-test, the normality assumption must be fulfilled. Another thing that you can take a look is this particular uh, confidence levels. Okay, if you take a look at this one, 40.5 and 47.8. Okay, 45 years old is in this particular intervals. Okay, 45 is in this interval, so that's why there is no significant difference based on alpha 0.05. Okay, you can try to adjust the alpha value if you want to do the to want if you want to explore more on this particular examples, right? And the description is in my notes. Okay, I hope that you understand what are the U and L here. All right, And then for this particular ODS graphic, okay, you don't have to worry about that, because when you use SAS Studio, you will automatically, the result will automatically give us the graphic, the graph. Okay, so that's why you don't have to worry about this. Okay, and okay, so based on this, when you take a look at my output, the legend only stated the 95% confident. Okay, suppose that you want to show the hash now. Okay, you can actually do this by take a look at this code. Okay, and I actually do some typo here, show hash now, and I use data time. Okay, this is different data compares to the previous one. Okay, so when I run this one, okay, right, I need to run this first. Okay, so when you run this one, okay, there will be null value here. So this particular line is showing the null value. Okay, so that's the difference between this particular code and this particular code, right? So you can try it on your own to take a look at the difference. Okay, and then we go to independent sample t-test, whereby you compare means from two independent groups. Okay, so based on these examples, what I will try to do is, okay, in the to test, okay, I want to do you use the same proc t-test towards the same data fitness. Okay, now if you don't specify anything in here, especially the size and alpha, it will use the default value. The default is size equals to 2, alpha equals to 0.05, and then what are the two groups that you want to compare to. So for this particular example, you want to compare gender, so you use class, okay, gender, and we want to test the significant is there any significant difference in running time before training, okay, between genders. So the variable here, the var statement, we put the variable that we want to test, which is r time b, okay, before training. Okay, and then you run. Okay, so based on this particular result, there are actually two steps that you need to know. Okay, first is let's take a look at the important information that we have here. This is the variable r time b, and this is the group female and male. Alright. Okay, for independent sample t-test, you have to take a look at the equality of variances assumption first before you can decide you want to use this particular p-value or this particular p-value. Okay, because depending on your equality of variances assumption, as example here, if equals, you use this one, if unequal, you use this one. Okay, so what are the things that you need to take a look at is this particular table. Okay, equality of variances, and take a look at the p-value. Okay, so if p-value is greater than 0.05, it means that, okay, you take a look at the the equal variances assume pi. Okay, so means that you take a look at the pole method p-value. Okay, so when you want to do the conclusion letter based on this test, you will report this particular p-value. Right, and I already discussed about the step here. Okay, you check the folded FP value first, and then use the pull row. So instead of 0.95, so we use 0.9469. Okay, to do the conclusion, right? And I mentioned the equality of variances hypothesis test to confirm that. Okay, we use the p-value from equal variances assumption. Okay, that's about independent t-test. And we have next we have paired t-test. Okay, so for paired t-test, we still use proc t-test, and then data fitness. Okay, and the statement that you have to use to perform paired t-test is paired. Okay, paired are, we want to take a look, is there any different is there any different in average time before and after a training program. Okay, so means that you want to investigate if this particular training program is effective or not. Okay, right. So for this particular proc t-test, since that you don't specify the sites and the alpha, they will use the default one lah. Okay, and then you run. Okay, so that's why they give us the 95% confident intervals, the mean, and the p-value is actually based on alpha 0.05. But when you take a look at this one, okay, the most important things that you need to know is this one and this one. Okay, and actually when we write this paired sample t-test, r time a equals to minus r time b, we actually want to figure out either this r time a minus r time b equals to 0 for the h null. Okay, r time, I put a minus b, a minus b equals to 0, whereby h1 a minus b not equals to 0. Okay, so means if the training program is effective, there should be a difference on the time. Okay, so that's why when you take a look at this particular confidence level mean, 0 is included in this particular interval, so that's why there is no significant difference. Another thing that you can report is the p-value. Okay, since the p-value is greater than 0.05, it means that there is no significant difference in average runtime before and after a training, right? Okay, so that's about paired t-test. Okay, and then what else we have in these notes? Okay, you can write the conclusion like this. Okay, you just report the p-value and the alpha value. Since that we don't specify any alpha here, you use the default one, 0.05. Okay, and for this particular ODS graphic, you don't have to worry. As I mentioned, in SAS Studio they will provide us with this respective charts. Okay, and suppose that you have more than two groups. Examples here, race. Okay, for the gender before this, we have two groups. So now we have another group that we want to test, but this particular race they have more than two, which is China, Indian, Malay, if I'm not mistaken. Okay, so the thing that you cannot use prop t-test. Okay, you have to use prop GLM. Okay, so let's take a look at examples. I put it in the same notes, even though that this is already topic 4. Okay, you can actually segregate the program files if you don't want to mess with the section number. Okay, I'll just save lah. Okay, I just save this one. Okay, I just save, and then I take a look at my folder, and then I put it as 3 compare means. Okay, I don't save this since that I already have my files here. Okay, and then for ANOVA, since that this is a part 4, I want you to start a new SAS program. Okay, right, so let's take a look at ANOVA. Since that the race variable is more than 2. Okay, so we use prop GLM. Okay, data equals to fitness. Okay, and class is the group, the variables that have a category more than 2 category. Okay, so now we're interested to study, is there any difference in time? Okay, the time after training. Okay, so you have to put model. Okay, our time A equals to race. Okay, and then means race slash. Okay, this is for this particular statement. Suppose that there is significant difference based on your ANOVA test, you can further investigate the pair, the means. Okay, the race, based on what are the comparison tests that you want to perform. Okay, for my example, I just used Tukey test. Okay, and then output. Okay, out residuals RE. Okay, and then run quick. Okay, so when you run this one, okay, the thing that you can take a look is the information here. The levels is 3, Chinese, Indian, Malay. So that's why we use ANOVA, and take a look at the p-value. Okay, so since that based on this the p-value is 0.3, there is no significant difference between race. So we don't have to further our investigation by using Tukey test. But if you take a look at my notes, my ANOVA table is quite different. Okay, so you can if based on the data, this is the result. Okay, so you just take a look at the output, but you can take a look at how you can write if suppose we get the p-value less than 0.05. Okay, if the p-value is greater than 0.05, you don't need to follow up with the compare means with the comparison test such as Tukey or Benferroni, post hoc test we call. Okay, alright, so that's the thing that we can take a look. And then uh, so for this code, since that we put out residuals, we can actually print the residuals. Data equals to residuals, and then you run. Okay, so this is actually the residuals based on the ANOVA. Okay, when you call the residuals, right? Okay, so that's about ANOVA, and we have another test in this part 4, which is chi-square test of independent. Okay, for this particular test, you will use if you have you want to check the relationship between two categorical variables. Okay, for this particular example, in data fitness, we have race and gender. So you want to take a look whether race and gender have association or not. Okay, so the procedure that we'll use is you will use PropFreq, because this is the same as cross tabulation step. Okay, table, race, gender. Okay, you put chi-square expected, and then you run. Okay, when you run this one, okay, this is the cross tabulation table, and the thing that you can take a look at when you perform this one is the chi-square test and the p-value. But notice that there is actually warning. Okay, there is actually warning. 100% of the cell have expected count less than 5. It means that here, okay, here the value is less than 5. So when the value is less than 5, it makes that this chi-square test may not be a valid test. Okay, because even when we take a look at this, the sample size is only 10. Okay, so that's why we expect that you cannot use chi-square test for this particular example. So instead of chi-square test, you can use Fisher exact test. Okay, when any expected count is below 5. Right? So let's do some modification towards our code. Okay, we add Fisher here, and then you run. Okay, now you will have extra table, Fisher exact test, and you report this particular p-value. Okay, don't report this, since that now the sample size is 100% of the cells have expected count less than 5. Okay, so when you do this chi-square test of independent, this is the factors that you need to take a look on. Alright. Okay, so for this video session, I will stop here and I will continue in next video. Thank you for